Hello, so this is just a review or demonstration of all the different calculations involved in the PSG report. So we've got our data over here, my calculator up here, and then this is where I'll be doing all the math over here. So the first one we're going to do is time in bed, and so from that we're going to go from lights out to lights on, and so you can just count and kind of do the math in your head, the difference between this time and this time. And how I do that is just we're starting at 22:07, which is 10:07 p.m. So I would go 10 to 11, 12, 1, 2, 3, 4, 5, 6. So there's 8 hours. What you didn't see was me counting on my fingers. So that was 8 hours, and then just the difference in the minutes. So we can count forward 7 to 15, so 8 hours, 8 minutes. If you wanted to then convert it all into the same increments, we can do 8 times 60 to get to minutes, plus that additional 8, so that's 488 minutes. But that seems kind of like a little confusing, which I completely understand. So, especially if the time, counting forward with the military time or that type of thing, like I said, I just counted on my fingers to do that. But another way to do it, which would get you the exact same results, is when you have the data presented to you like this, where you have not only all the epochs of sleep, but also the epochs of wake. If we were to add up all those epochs, so 141, oh, let me click on the calculator. 141 plus 407 plus 82 plus 154 plus 192, that equals 976 epochs. To convert epochs into minutes, you're just going to come over here, divide by 2, and again, 488 minutes. I find that way to be a lot easier than trying to figure out count forward or backward with the time and counting on my fingers. So if you have epochs of wake as well, that will give you your time in bed or total recording time if you just add all of those up. And whenever I write out my data, I always try to put in whatever increments I'm in, so I don't get confused like, did I convert epochs into minutes? Because you always want to make sure that when you're doing your math, that, like, say for instance, when you're doing sleep efficiency, that the increments are the same. If you're doing it in minutes, they both have to be in minutes. So for total sleep time, we're just going to add up all of our epochs of sleep here. So that would be 141 plus 407 plus 82 plus 154. That's 784 epochs, which converted into minutes. So we're just going to divide it by 2 because there's 2 epochs in every minute, because 1 epoch is equal to 30 seconds. So that's 392 minutes. I'm going to further convert this to hours because we'll need that total sleep time in hours when we do all of our indice calculations. So to convert minutes into hours, we divide by 60, and that is going to be 6.53 hours. So for sleep efficiency, you can do either, it's just total sleep time divided by time in bed, and we can do it in minutes or we can do it in epochs. It doesn't matter, the math will equal the same as long as you're using the same increments for both. So what I mean by that is if we're using epochs, it's going to be 784 divided by 976, and if we're doing minutes, it's going to be 392 divided by 488. Regardless, it should equal out to be the same. So I'll do the first one as 784 divided by 976, 80.33%. Or if I do it in minutes, 392 divided by 488, it's the same, 80.33. So as long as you're keeping the increments the same, that you'll be able to get the percentage correctly. And just going back to, high school math or, converting a number into a percentage, if you don't understand how I got 80.33 from this number, all you do is times it by 100, and that's your percentage. So sleep latency latencycy is how long it took the patient to fall asleep, the first epoch of sleep from lights out. So lights out was at 22:07. Sleep onset occurred at 22:52. So you just have to find out the difference between these two numbers because it's within the same hour. I just can minus the minutes from each other. So 52 minus 7. So sleep latency was 45 minutes. REM latency is the distance between when the person fell asleep to when they went into REM, not from lights out, but from when they fell asleep, from sleep onset to REM onset. So it's the distance between these two numbers here. So from 22:52 to 01:22. So 10:52 p.m. to 1:22 a.m. So again, for this one, you're just gonna I tend to just start here and I count forward and count on my fingers. So 10:52 to 11:52 to 12:52. So 12:52 then to get to 1:22 is another 22 plus another 30 minutes. So that's 2.5 hours. So 2 hours is 120 minutes plus 30. Oh, what did I do? Where am I writing that? So the distance between sleep onset, REM onset is 2.5 hours. If dealing in these little numbers are difficult, like 52, 22, another thing that I've done in the past to kind of make it easier or work easier in my brain is I'll round up. So like 22:52, I'll round up to 11 p.m. So from 10:52 to 11 p.m., that's 8 minutes. And then 8 minutes on to here, so that's 1:30. So the difference between 10 p.m. and 1:30 or 11 p.m. and 1:30 a.m. I don't know if that helps, but essentially, use your fingers if you need to, because I certainly do. You're just counting the difference between this time and that time. And it was 2.5 hours. So, 2.5 hours. If we wanted that into minutes, you're just going to go 2 times 60 plus the additional half, which is 30, so 150 minutes. For the time in stage 1, you're just converting the epochs into minutes, so that's just going to be 141 divided by 2, so that's going to be 70.5. And then we're going to further convert it into a percentage, so the percent that the patient spent from in stage 1. So for that math, you're just going to use your total sleep time, but you want to make sure the increments are the same. So because this is in minutes, we're going to do 70.5 divided by 392 in order to get that percentage. And if I kept it in epochs, I could still do 141 divided by 784 and the number will be the same. But so divided by 392, that's going to be 17.98%. So the time in stage 2 is going to be 407 to convert epochs to minutes. It's going to be 203.5. And again, to convert that into a percentage, I'm going to divide it by the total sleep time. That's going to be 51.91%. Time in stage 3 is 82 epochs, so that's 41 minutes. To convert that into a percentage, we're doing it the same exact way. So divided by the total sleep time in minutes. So it'll be 41 divided by 392 or 10.46%. And then the time in REM is 154 epochs. Converting that to minutes, it's going to be 77 minutes. And to convert that into total or percentage, same way as the other stages, 19.64%. So if you're questioning your math, one way to kind of double check your work is add up all of these numbers. That's they all comprise the percentage of the total sleep time. So all of these percentages should add up to 100. So if I were to do 18, just to kind of round up quick to do my math, plus 10, plus 20, yeah, they do. They all add up to 100, so I know I did that correct. So if you maybe deviated or maybe used the time in bed to do this calculation instead of total sleep time, add up all these numbers quick just to make sure they add up to 100. And if they don't, then you made a mistake somewhere. So total wake time is how much time the patient spent awake throughout the entire time that they were that the recording was going. And so we can do that by just minusing time in bed minus total sleep time. And again, you can, if we do epics, we just have to make sure we stay in epics, or we can do minutes. I like to do minutes. So it's just going to be 48 minus 392 to equal 96 minutes. Another way to do this, though, is when you have wake over here, that's your total wake time right there. It's the same. So say you forget this formula right here. When you're given the wake, you're given it right there. That's your wake time. So if we were to convert epics to minutes, 192 divided by 2, it's the same, 96 minutes. So for our WASO, there's the full formula right there, which is time in bed minus total sleep time minus sleep latency, because it's wake after sleep onset. We already did this component of the equation, so you can just even further go down to just do total wake time minus your sleep latency. So it'll be 96 minus 45. So 51 minutes for our WASO. And then next we're going to go down and do all of our indices. So for indices, remember, and I'm going to write this out, you're always going to divide by your total sleep time in hours. I even made that bold for you. So your arousal index is just your total number of arousals. Where is that number? 105 divided by our total sleep time in hours. Total sleep time, hours. The reason why we use total sleep time is because we're only doing the math for while the patient's asleep, not for while they're in bed, because you're not going to have apneas, you're not going to have awakenings or arousals when you're awake. So that's why we don't use time in bed. That's why we use total sleep time. So if you forget that, it's something you're going to just mess up the whole column. But just kind of understand why we use total sleep time, because it's how many average arousals they had on average per hour of sleep. That's kind of the definition of the index of any of these, is the average number of these events per hour of sleep. That's why I use total sleep time. So for our arousal index, we're just going to do 105 divided by 6.53. So the arousal index is 16.08. Apnea index is the total number of apneas they had. So we're going to add up the total number of obstructive, mixed, and central. So 17 plus 5 plus 1, so 23 divided by, and I can write this out too, so you can kind of see how I'm doing by math, 6.53. Let me come over to the calculator. 3.52. Your AHI is apnea and hypopnea, so we're going to add up all of these, the next 4. So it'll be come back over to the calculator. 17 plus 5 plus 1 plus 31, so that's 54 divided by 6.53 to get that number. So 8.27. Then your RDI is you're going to combine all of your respiratory events. So 17 plus 5 plus 1 plus 31 plus 48 is 102. So 102 divided by 6.53. And I'm just writing it out here, so if you do better visually to see what I'm doing, to see my math, you can see how I'm getting these numbers. So the RDI is 15.62. PLM index is just 98. So total, oh, back over here, 98 divided by your, again, total sleep time in hours. So PLM index is 15. PLM or number of arousals from the PLMs is just 13 divided by 6.53. So 1.99 for this. I got all my numbers, and having all my numbers laid out for me right there now can help me to kind of do my evaluation. So obviously we use total sleep time to do a lot of our numbers. We use it to figure out sleep. We use it in the calculations for sleep efficiency. We use it in the calculations for the percentages in the sleep stages, for your total wake time for your WASO, and all your indices. So if you get total sleep time wrong, it can really kind of throw you off for your rest of your calculations. So this is probably the most important one. If you're short on time, just come back and check this one to really make sure that you got that one right. So we're going to evaluate our patient's sleep architecture. For this, you're just going to really look at time in bed, total sleep time, sleep efficiency, sleep latency, REM latency, all of these numbers, and I also include my arousal index to kind of do an overall evaluation. So the patients spent a good amount of time in bed, but they only slept for 6.5 hours. So you can even shorthand this. You know, time in bed was normal for an adult, but total sleep time was reduced or less than the recommended 7 to 8 hours. Oh. Sleep efficiency, or we can even go even low, sleep efficiency was reduced, and sleep latency was prolonged, which means that the patient had trouble falling asleep. They also, we can go down to our WASO. Let's look at how much our WASO was. WASO wasn't really too high compared to their time in bed. Remember, WASO is about 10% of your time in bed. So if 10% of 488, if we just move the decimals, like 49. So WASO wasn't bad. So really the sleep efficiency was reduced mainly because the patient had trouble falling asleep. Sleep efficiency was reduced, sleep latency was prolonged. So we'll do that. And WASO close to normal, which ultimately means that the patient had trouble falling asleep, but not so much staying asleep. Alrighty, so REM latency was prolonged as well. Patient had normal N2, close to normal REM, increased stage 1, and reduced N3. So I would really highlight what's abnormal here. So increase in stage 1 and decrease in N3 shows that quality of sleep isn't what it should be, you know, isn't as good as it could be. There's a bunch of different ways to say this, but really that you're highlighting that you understand that the lighter stages of sleep are increased, whereas the deeper stages of sleep, you know, stage 3 is diminished, but it could be normal. We don't know depending on the age, but we don't have that. So how about we just say increase in N1 and decrease in N3 shows that the quality of sleep is impacted. Done. Arousal index shows that they have moderate sleep fragmentation because we're using this same mild, moderate, severe criteria rating over here as we do for the RDI. But here, this is where I'm going to go down and formulate a diagnosis. RDI demonstrates the RDI is above 15, so moderate sleep apnea. And I'm going to say it's obstructive sleep apnea because mainly the number of respiratory events they had came from apnea, obstructive apneas, hypopneas, RERAs, and those are all encompassed under the umbrella of obstructive sleep disordered breathing. So moderate OSA, AI equals that the patient had moderate sleep fragmentation, and positive for the diagnosis of PLMD because their PLM index is 15 or greater, and it is. So they are right on the cusp of being positive for the diagnosis of PLMD. So all of this, can be done as long as you know your equations. You can work it out pretty quick and then kind of have an idea of how you want to, evaluate the sleep architecture. I think if I was in a testing situation, I would get my math done and just jump down here and do this really quick and then spend my time kind of really elaborating what I want on how much I can and want to go into on their sleep architecture. If you're doing this on the computer, what you can do is use the blank PSG form that you've got. It's on Blackboard too, to kind of do it mathematically. I find it's really a lot more helpful for me to do it all here and have all the numbers right in front of me for when I'm doing my evaluation versus scrolling up, scrolling down. But if you have any questions about any of the math that we did, feel free to either comment on this video or shoot me an email or ask it in the question discussion board. Thanks for watching.